Okay, so yesterday we started dynamics, and today I have posted a practice question set. I believe that is 3, and that covers dynamics. So start working on it, and the questions you can solve right away, and some of the material we'll cover today. If we cannot finish it today, we'll finish that tomorrow. But the practice question set is due by 23rd, Saturday. And most probably the quiz will be due by Sunday. Okay? So I hope you are already preparing for the quiz. The basic difference between kinematics and dynamics is the discussion about the force that is involved. We're still using those 3 equations of motion. A typical dynamics question is when acceleration is missing, but you are given the value of the force and the mass. So from F and M, using F is equal to ma, you can find acceleration. And once you have the acceleration, you can plug that value in any of the equation of motion to solve that problem. So that's a typical dynamics problem. So yesterday we were solving the problem about related to the jetliner. We solved the first part of it, and we found the speed, and that was 133, I believe. 17.77 meter per second. So now the second part. The second part is what is the distance traveled. So again, the question is a jetliner begins to slow down after landing. So we know right away that acceleration is going to be negative here. Its mass is 3.5 into 10 power 5 kilograms, and speed is 27 meters per second. Net braking force. So braking force means that something is trying to slow this down. So that will certainly be in the direction opposite, in the opposite direction to the jetliner motion. As in reference to what is the distance traveled during this time? So we already know initial velocity. We know final velocity. We have figured that in the first part. We know the time. The time is basically our scope. So our scope begins when it just starts to slow down, and we start paying attention to that. And 7.5 seconds is where is the end point of our scope. After that, whatever happens, we don't care. Our scope is done over there. So let me get the pointer here. Okay. So we need to find out S. So what information do we have? We know A. We found that in the first part. We have to find out S. The time is given. VF, we know that now, 17.77, and VI we already know. So at this point, we have a lot of information that we can use. So we can pretty much use second or third, any of these. First is not going to help us because we need to find out S, and S is not involved in first equation of motion. So I'm just leaving it to you. Plug the values, and the answer should be very close to 168 meters. So try it and let me know if you experience any issues with that. Third law of motion, very interesting. So far we have covered 2 laws of motion. Third is, for every force that acts on an object, there is a reaction force acting on a different object that is equal in magnitude and opposite in direction. So that is very important to understand that these forces are in pairs and these are different objects. For example, when the car moves forward, the tire exerts force on the road, and the road exerts force on the tire. So these two forces are action-reaction, and you can see in both cases, for the both forces, the actor is different, the victim is different. This is very important to understand. These forces are always in pair, action and reaction, act on different bodies. In the first case, it is on the road. In the second case, it is on the tire. When you accelerate car from rest, tires exert force on the road, it is action. Road exert equal and opposite force on the car, that is reaction. Now, now we are going to talk about our friend, friction. When we talk about friction, we do not have very nice thoughts about that. The first thing that comes to our mind is the friction involved in the car, in moving objects, where we have to use grease or lubricants to minimize that friction. But at the same time, we need to appreciate the fact that without friction, we cannot really do anything. We walk because of friction. If you do not believe that, throw some cooking oil on the floor and try to walk, and you'll see what happens. On the other hand, you cannot apply brakes when you are driving. So that is all. For all that, we have to be thankful to friction. When two bodies interact by direct contact of their surfaces, the interaction forces are called contact forces. So every contact force has two components. Again, every contact force has two components. One is parallel and other is perpendicular to the surface. So we have, let's draw it here. Let's say we have a desk, and then we have a box sitting on that. So if we move this box, if the box is just sitting there, let's say, then there is one force that is already always acting on this box. So what is that force? Tell me. We are going to begin a very important discussion here, so pay attention. Gravity, okay. Who else? There is one force that is always acting here. What is the one force that is always acting on an object? We cannot rule out, we cannot remove that force as long as we are on the surface of the earth. Yeah, it's gravity. So of course, your first answer was correct. So gravity is always there. Now there is a problem. Let's say this is a desk. And these are the legs of the desk. Now, there is a downward force. So if there is a downward force, and the box is still at rest, it is not going downward, then there has to be an upward force that is canceling this downward force. Does it make sense? Otherwise, this box should be moving downward, right? So if it is stationary over there, it is not going downward, not going upward, it means that there's a downward force, gravity, but there is some upward force as well, and that is exactly equal to the gravity, and that is keeping this box over there at rest. Does it make sense or not? Excellent. Good. So now, what is that upward force? That is the normal reaction of the desk. So, okay, we have this fancy word, normal reaction, but where is that coming from? Now, that is really different for different objects. For the desk, it is basically the intermolecular forces that are bonding all the molecules together, the desk molecules. So those forces are actually causing, ensuring that the desk stays in place and does not break. So let's say that we have a piece of paper and we put 250 gram load on it. So of course that will try to tear through the paper, but paper is strong enough to hold that. So at this point we have a downward force of gravity and upward force of normal reaction. Both are opposite in direction and both are the same magnitude. Okay, so the molecules are just hanging in there, trying to stay together so that the paper stays in peace. And we add 5 more grams. The paper still stays. But the molecules, the force, the normal force is also increasing, because when you increase the load on it, the downward force is increasing. I'll tell you what is the downward force. And to counter that increase in downward force, the upward force has to increase. Now there will be a point where the upward force will give up, because the strength of the paper determines that limit. And at that point, what will happen? The mass will just tear through the paper. It will drop down. So now what is happening? The upward force is not there. It just got removed because the paper is not there to stop it, and the mass starts doing what makes sense, going downward under the influence of gravity, right? Now, what is that downward force? That downward force is the weight of that body. And how do we find that? Yeah, gravity gives the direction, determines the direction, and the mass determines how much force will there be. In the next discussion, I'm going to address that part. So that force with which the downward force, actually, what is that downward force? That downward force, let me type it. That is weight, and we use W to represent that. And W is equal to mg. And m is basically mass of the object, like kilograms, and g is gravitational acceleration. So, as we have already established that for physics 1 and physics 2, we are going to use g is equal to 10 meters per second square. Actually, it is 9.8 meters per second square. So, if something, the mass of something is 10 kilograms, what will be the weight of that object? That will be 10 multiplied by 10 is equal to 100 newtons. Okay, weight is measured in newtons. So what else is measured in newtons? Can you tell me? Force, exactly. So weight is just another force. Okay, just like length, width, thickness, these are all lengths. Similarly, force, weight, these are all forces. Weight is the force with which the earth tries to attract a body towards its center. Okay? The weight of the object is the force with which the earth is trying to attract that object towards its center. So for example, if some person is 60 kilograms, right, what will be the weight of that person? That will be 60 multiplied by 10, 600 newtons. So the earth is trying to attract that person towards its center with a force of 600 newtons. Does it make sense? Is that clear? How to find weight? What is the difference between weight and mass? Excellent. Good, very good. So on the moon, nowhere, weight is never equal to mass, because the only thing that changes on the moon is g. So value of g is different. So what will happen, g is less on the moon as compared to Earth. I don't have the exact figure right now, but because it is less than that, so the same mass will have lesser weight on the moon. So the attraction, the force with which moon is attracting that object towards its center is way less than that of Earth. That's why the people, when we look at the video of Neil Armstrong walking on the moon, he is essentially jumping there. So this is all because of the less gravitational acceleration, lower gravitational acceleration. On the other hand, on Jupiter, on the Sun, it will be way more than that. So that brings us back to the joke. I come across that every now and then on the social media, and in the old times I used to correct the person. I don't do that anymore. That is that if you are 60 kilogram on the, let's say 100 kilogram on the Earth, you will be like 40 kilogram on the moon. You are not bulky. You are just on the wrong planet. So, but the thing is, the bad news is, if you are 100 kilogram on the Earth, you will be 100 kilogram on the moon, you will be 100 kilogram in the space, you will be 100 kilogram on the Jupiter, everywhere in the universe, unless you lose a limb or something. Because mass is actually the amount of matter in your body. That does not change, right? It is a weight that changes from location to location in the universe. If you are on the Jupiter, it will be huge, the value of weight. If you are on the Earth, I'll just multiply your mass by 10 and you know the weight. On the moon, it will be less than that. In the space, it will be again less than that. So that is very important concept. You should know that the mass does not change. It is a weight that changes. And weight is what? It is actually just a force. Okay? And it is always downward because of the gravity. So gravity determines its direction. If weight is there, then there has to be some upward force to counter that. If the upward force is enough, is available, then fine. Otherwise, the surface will break and give away, and the object will start falling downward. So, and then it lands on the floor. Okay, not lands on the floor, it cannot go any further because the floor is just solid. Then what happens, we know now, that the downward force is the weight of the object, but the upward force that the floor is exerting on it is just equal to the weight of the object. Remember that. It is not more than the weight. Okay? The upward force that the floor, no matter how strong the floor is, the upward force that floor is exerting on the object is just equal to the load, the weight of that object. Why? Because if upward force is more than the weight, the box should be moving upward, right? But that doesn't happen. Both forces are canceling each other. That's why the box is stationary. Okay? Yeah, trampoline is different. I'm not talking about that. That is elastic material. So what happens when you jump on it, it stretches, and now it has to come back. When it comes back to its shape, what happens? You, as a result, go upward. So that's a different story. Yeah. And on the other hand, when you're talking about trampoline, you are not talking about a stationary object or an object in equilibrium. You are talking about a moving object. So I am referring to an equilibrium situation here, where all the forces are equal to zero. And again, trampoline is a very good example to explain. If upward force is more than the weight, then the body has to move upward, right? Good. So these are the concepts that in the beginning, they don't make much sense. The first thing that you can challenge is that how come the force that the floor is exerting on the object is not huge, because the floor is concrete, or even if it's sand, whatever it is a very strong surface, but it is not applying a lot of force on it. So now when you compare those two forces and you put all this in a scenario and you connect the dots, then it makes sense to you that, okay, if the net force is downward, the object has to go downward. If the net force is upward, the object has to go upward. If the object is stationary, it means that upward and downward forces are equal. And that is exactly what is happening here. So it also tells you that if you put something on the floor, it is 10 kilograms, then what is the upward force that the floor is exerting on the object? You put something on the floor. The mass of that object is 10 kilograms. What is the upward force that floor is exerting on the object? Yeah. So what is that? Weight of the object, not the mass. So you have to multiply this by 10 by G, 100 newtons. Okay, yes. If the mass of the object is 10 kilograms, its weight is 10 multiplied by 10 equal to 100 newtons, right there on the whiteboard. So if its weight is 100 newtons, it means that the downward force that box is exerting on the floor is 100 newtons. So the floor is exerting an upward 100 newton force on the box. So that's why the box is there. If I add 1 more kilogram to the box, now the mass of the box, total mass, is 11 kilograms, and the weight becomes 110 newtons. The floor will compensate that and the force, upward force from the floor will become 110 newtons, just to cancel that. Okay? So that concept is very important, you should know that. Now, perpendicular component is the normal force. We just discussed that. And this N is in italic, so don't confuse that with Newton, the unit. Horizontal component is friction. Again, italic F I'm using so that you don't confuse that with force. The friction can be of two kinds, kinetic and static. What is that? F, K for kinetic, and N are always perpendicular and directly proportional. For a sliding body, Fk is equal to mu Kn, where mu K is coefficient of kinetic friction. So what if you actually these coefficients are available in the engineering books, or you can just Google that. For example, value of kinetic friction. Just Google that, and you will see a table. Concrete this much, steel this much, steel wood this much, wood this much. So these are predefined values. So these are constants, okay? And if you know the force, you can find the normal, friction, you can find the normal force. If you know the normal force, you can find friction from there. So kinetic friction is that, mu K multiplied by N. And how can you find N? Well, you just need the mass. If you know the mass, you can find weight. If you know the weight, N is exactly equal to that, just opposite in direction. So if you know mass, finding normal upward force is no problem. Just multiply that by mu K and you have the force of friction, kinetic friction. Static friction. Static friction has a magnitude between 0 and mu Kn when motion is about to start. So now this is very important and maybe a bit confusing. Why is that between 0 and a certain maximum value? Okay, let's talk about that. It is again, the basic point is if the net force is not equal to 0, there has to be a motion. Okay, now, an object is sitting there, and now there is a force of friction. That's why it is sitting there, otherwise it can be moving around. Now what I do, I apply some force on it. It doesn't move. I apply more force on it. It doesn't move. So I push it really hard and then it starts moving. So what happened there? Now let's say let's say we have this object sitting on the floor, and let's say the maximum force of friction that is possible between these two surfaces is 10 newtons. Just assume. Okay, and that 10 newton is basically this value. I have already told you that it is between 0 and this maximum value. So, now, if you are not applying any force, the force of friction is 0. You should know that. Okay? Because force of friction is in the direction opposite to the applied force. So you are trying to push it in this direction along positive x-axis, like this. So the force of friction will be along negative x-axis. So if you are not applying any force, friction will be 0. Now, what happens? You apply 1 Newton force on it. The force of friction will increase to 1 Newton, just to counter your applied force. Okay? And what is the net result? The box stays stationary. Now you apply more force. You increase that to 5 Newton. The force of friction will increase to 5 Newton just to counter your applied force. Okay? Now you increase your force to 11 Newton. Now the force of friction can go only up to 10 Newtons. So it cannot be 11 because that is the maximum in this scenario. So what will happen? The box will start moving. Okay? Now you are applying 11 Newton force and the friction is 10 Newton. So of course the net force that is acting on the object is the difference of these two, and the net 1 Newton force actually caused this motion. Is that clear? Very good. So the most important point from this discussion is that the static friction is a variable. It depends upon the force you are applying, and it has any value between 0 and the maximum value. As long as your applied force is less than that maximum value, the object is not going to move, and the force of friction will be just equal to the force you are applying. Once the box starts moving, then you have come out of the domain of static friction. Now you are talking about kinetic friction because the box is moving now, right? So this discussion is irrelevant now. So now you need to find out those values over there. So as long as the box is stationary, you stick with Fs is less than or equal to mu s multiplied by n, and you solve this problem. So that was very important to understand. Very good if you got it. Now let's solve a problem, and this will also bring the discussion of free body diagram. These diagrams can be complicated, but we'll stick with the simpler ones. The difficulty level is not too high for physics 1. So you have to push a 500 Newton cart with horizontal force of 200 Newtons to move it. Once it has started moving, you can keep it moving with only 100 Newton force. So now you can see clearly that there is a difference between the static case and moving case, kinetic case. What are the coefficients of static and kinetic friction? So first, let's have a look at the free body diagram. So how to make one? Of course, I'm not going to ask you to make a free body diagram in exam, but it is helpful if you are solving the problem. To solve a problem related to equilibrium of a particle or body. Again, what is equilibrium? For equilibrium, acceleration has to be 0. So it means that either the body is at rest or it is moving with constant velocity. In both cases, it is equilibrium. Okay? So draw a simple sketch of the problem, choose the body in equilibrium, and draw a diagram of that body. Without including interacting bodies, show all the forces. Draw a set of coordinates, and then now you're going to do the same drill you have the forces, just dissolve those forces into components and solve the problem. So let's take a look. A 20 Newton force is moving a box on a frictionless plane, so there is no friction here, along horizontal axis at constant velocity. So we just need to find out, we just need to draw this free body diagram. No movement along y-axis. So it means that the forces along y-axis are balancing or cancelling each other. Downward force is the weight of the object. If the mass of the object is 10 kilograms, then the weight of the object is 100 Newton, and the upward force will also be 100 Newton. Okay. Now, the force along positive axis is 20 Newton. So we have all these three forces there. So that is important, that if whenever you are going to start this, making this free body diagram, the weight is the first force. You know that. It is always there. You cannot get rid of that. So just mark that first and then do anything else. If friction is involved, let's say 20 newtons, then what you do, you apply, you just make another arrow over here and just type 20 Newton. Cancelling out, yeah. And the box will be stationary, not moving at all. Very good. Before that, let's say we have a box sitting on the floor. Okay. The mass of this box is 20 kilograms. The mass of this box is 20 kilograms. How much force is the floor exerting on the box? Quick. Excellent. Yes. Because the mass is 20 kilograms, it means the downward force, that is the weight of the box, that is 200 kilograms. 20 multiplied by G. G is actually 9.8, but for physics 1 and 2, we are taking it 10 meter per second square. So that will be 20 multiplied by 10 equal to 200 newtons downward force. If the box is staying there, then there has to be an equal upward force, and that is the force that the floor is exerting on the box, and that is equal, so that is 200 newtons. Excellent, very good. Let's talk about another thing. This box is hanging by a string box, let's say chandelier or something like that, is 5 kilograms. What is the tension in the cable? That is again the same thing, but I just wanted to introduce you to this new concept, tension. The weight of this object is 5 multiplied by 10, 50 Newton, very good. Because this object is not falling down, it is stationary. it means that the string or the cable is applying the equal amount of force in upward direction, and that is actually the tension in the cable. Okay, so that is equal, so 50 Newton, and it is upward. The weight is downward, tension is upward. Excellent, very good. Now let's solve it. So we have a situation here where the box is suspended from two ropes. So let me draw that for your convenience. The box is like this, and then we have two ropes like this, and then let's say this is the ceiling or some platform. Okay, 100 Newton box. 100 Newton means what is the mass of this box? What is the mass of this box? 100 Newton. Yeah, 10 kilogram. Try to report the unit as well. That will be just good revision for you. 100 Newton box is means 10 kilogram. It's suspended from two ropes, each making a 40-degree angle with vertical axis. Okay, so this is our diagram. This is the vertical axis, y positive, not negative. Okay, now find tension in each rope. So we have this angle here. Okay, we have the downward force, and we need to find out these TL and TR. Okay, now how to do that? First of all, of course, we already have the free body diagram, so that's done. Again, this should be positive. Okay. So now the next step is to resolve these forces into the components, X and Y components, because we cannot really do anything with these forces along an angle. We don't know what is the length of it, what is the magnitude of it. So how to do that? How to deal with that? We just resolve that into components, X component, Y component, and then we can solve that part. So sorry. Look at this one. This is a simplified case. Downward force is minus 100. Remember, because it is along negative y-axis, so minus. Don't forget that. Minus 100 Newton is the weight. Upward force. So for TL, we are going to resolve that into its components because it is 40. So this one is adjacent, and the line over there, that will be the opposite. Okay, so just using SOHCAHTOA, this will be TL cos of 40 degree, and that will be TL sine of 40 degree. Okay. Similarly, we have TR cos of 40 degree over here and minus TR sine of 40 degree over here because it is along negative x-axis. So now we have very understandable. You can understand that, and you can do something with that. This is the situation. So we have three vertical forces. Two are upward and one is downward. And then we have two horizontal forces. One is towards right and one is towards left. Is the box moving along positive or negative x-axis? Do you think so? Is the box moving along negative or positive x-axis? Is there any horizontal motion? No, there is no horizontal, no vertical motion. Right? It is suspended, so it is stationary. So there is no motion. It means that the left force should be equal to right force, right? So TL sine of 40 degree should be equal to minus TR sine of 40 degree. This is what it means. On the other hand, the box is not moving upward or downward. It means that the vertical forces should also be equal to 0. So it means that TR cos of 40 degree plus TL cos of 40 degrees should be equal to minus 100 Newton. That's the only way we could balance these two forces. So let's solve it. TLX is equal to TL sine of 40, and that is 0.64 TL. Just open Google and type sine 40 degrees. The answer will be 0.64, something very close to that. Similarly, TLY is equal to TL cos of 40 degree, again 0.77 TL. TRX is equal to TR sine of 40 degrees, so minus 0.64 TR, because we have already established the negative sign over here. TRY is TR cos of 40 degrees, so 0.77 TR. Kosi, you have a question? And the angle? Yes, we can use that, but that will be very complicated. The reason is in the statement, it is just given that these ropes are making angle 40 degree with the vertical axis. So we just need to rotate our triangle rather than shifting our reference for the angle all the way. So I guess that will be easier. It is just about what is more convenient. And W is equal to, sorry about that. And W is equal to minus 100 newtons. The box is in equilibrium, so zero net force. What does that mean? Vertical force is equal to 0, horizontal force is equal to 0. So what are horizontal forces? 0.64 TL minus 0.65 TR is equal to 0. Basically, it is basically plus minus 0.64 TR. So that's it. So when you solve it, you get TL is equal to TR. So that's done. That is one thing we got from this half of it. Now, y components. 0.77 TL plus 0.77 TR minus 100 equal to 0, because net force has to be 0. Now just again simplify that. Just take 100, add 100 on both sides, and then divide both sides by 0. Actually, sorry. Over here, TL is equal to TR, so we just replace this TL by TR, and now just add these two. And you have 1.54 TR, and TR is equal to 65 newtons, approximately equal to. And because TL is equal to TR, so TL will also be equal to 65 newton. So that is a very typical way to solve the problems related to equilibrium. Any question or confusion here, please let me know. Okay. This is friction. It is hard to make one up that is as complicated as this one is. Well, there is one problem in the practice question set, so try that. And if you run into any problem, let me know. Okay? Good. So you have to push a 500 Newton cart with horizontal force of 200 Newton to move it, just to move it. So this actually hints the maximum amount of static friction there. So Fx, again, if you draw the free body diagram, Then Fs is along negative x-axis because by default we take that the motion is along positive x-axis unless we are given the other information. N is upward force, the normal, and W is downward weight of the object, and 200 is the force we're applying on it. So this is your free body diagram pretty much. So because the horizontal forces should be equal to 0, this is, you can consider this another example of the previous discussion, but of course it involves friction. So Fs and 200 Newton should be equal to 0 because it is about the balancing of the forces. So Fs is equal to 200 Newtons. Now Fy, again, upward and downward should be equal to 0. So n minus 500 equal to 0 and n is equal to 500 Newton. So the coefficient of static friction will be equal to Fs is equal to mu s n. So mu s is equal to 0.4. Now you can think that, okay, Moid cheated a bit over here because the cart is moving. Then how can we assume that it is under equilibrium? Well, we cannot. But what happened just below 200 Newton force? Because you have to apply 200 Newton force, right? At 199, the cart was not moving. At 199.99999, the cart was not moving. So what we did, we just took that limit where the cart was still stationary. At 200, it just started moving, but just before that, a little bit before that, the cart was stationary. So we can apply that discussion of equilibrium here. Okay, so that's very important to understand. Now, once it has started moving, you can keep it moving with only 100 Newton force. So now we have moved into another domain. Now we are talking about the kinetic friction. The static friction is gone. It is old story. Now, again, we have this free body diagram. Now you can see we have Fk here, not Fs. And 100 Newton force is enough. It was 200 Newton to move it, but once it has started moving, then you can usually you need lesser force to keep it moving. That's why it is very, very hard to get up in the morning. But once you are up, then it is very easy to get other things done. So Fk should be equal to 100 Newtons because now it is moving with only 100 Newton force, and we can assume that it is moving at a constant velocity. So Fk is equal to 100 Newton, very simple. Fy, the normal force, the vertical forces should also be 0. So n is equal to 500 Newton. Put these values, and you have mu k is equal to 0.2. So clearly mu k is less than mu s. So these are the typical questions related to friction. That was all about dynamics. As of now, we have finished fundamentals, kinematics, and dynamics. So I am going to open quiz today, and that will be due by Sunday. Okay, so take your time finishing kinematics practice question set, dynamics practice question set. Only after that you attempt the quiz. Okay, not before that. And again, the quiz is one chance. You cannot repeat that. You can review as many times as you want. Any question, let me know. I'll keep the session open for 6 more minutes. So, and then you have 30 minutes to work on your practice question set. We can review the quiz. You said yes, you can. Yeah. How many questions in the quiz? Okay, and this is the second time I'm getting this question. So let's over here, quiz 1. It may change a bit, so don't trust this too much. page. Paste. That is the typical anatomy of quiz 1. Okay, and okay, so now you can see that the P means problem and C means conceptual question. So a conceptual question from kinematics, for example, if velocity is increasing, then acceleration is negative. Is that true or false? If velocity is increasing, then acceleration is negative. Is that true or false? Yep. If velocity is increasing, then acceleration is negative. Is that true or false? Very good. Yes, it is false, because if velocity is increasing, then acceleration has to be positive. Good. So that is the kind of question you are expecting when it says C, conceptual question. And P, just like one we just solved, the box is hanging with 2 strings, blah, blah, things like that. So again, it may change, but this is I'll share this information with you, what will be included in quiz 1. And the formula I use to calculate the time allowed for that is 2 minutes for each conceptual question and 4 minutes for each mathematical problem. So for this particular quiz, I would give you 68 minutes. 68, yes. You can just add that. You can just do the math. 4 plus 2 plus 4 plus 4 like this. And I see 3 question sets already. Are you opening an additional? No, I have already opened that. That is the 3rd one. I'm not sure what is the 3rd one, but the one practice question set that is due by 21st, day after tomorrow, that is kinematics, and the second one that is due by Saturday on 23rd, that is about dynamics, and then the quiz is will be due by Sunday midnight. And then next week we are not holding any pre-med physics sessions, so I'm not sure if it is good news or bad news for you, but we'll be switching to block 0 physics and we'll be finishing that. And after that, then it will be your exams, then will be block 2, your exams. Okay, and then after these 2 exams are over, and then we'll come back. I'm going to stop recording here, and if you have any questions, please feel free to